Alright, welcome back everybody. In this video we're going to look at examples 4 through 6 from the Substitution Part 1 lesson. Training wheel's still on, so we're going to tell you what your substitution is. So look at example 4. We're taking the integral of the quantity 12x squared plus 16 over the quantity x to the third plus 4x raised to the third dx. And we're told here that our substitution is going to be u equals x to the third plus 4x. Notice that once again, this is an expression that is inside of another function. In this case, it's what's being raised to the third power in our denominator. That's what makes it an effective substitution choice. So we'll go through this much like we did the other ones. We've got u equals x to the third plus 4x. And so du is equal to 3x squared dx plus 4dx, or factoring out the dx, the quantity 3x squared plus 4 times dx. I would normally skip this second step altogether where I took the 3x squared dx plus 4dx and just go to the final, because I know since all of these terms contain x in my u that I'm going to have a dx times everything at the end. I would normally jump right to the du equals the quantity 3x squared plus 4 dx. Okay, so let's look at everything that's left over. Once we make our substitution, we've got the integral of something over u to the third. And let's take a look at everything that's left once we do that. And we've got 12x squared plus 16 dx. So we'd like to replace 12x squared plus 16 dx. We know that du is equal to 3x squared plus 4 times dx. So if we multiply both sides of this expression by 4, we find that we have exactly what I've highlighted here in turquoise that we want to replace. And so we'll replace it with a 4 du. I'm going to just go ahead and bring the constant multiple 4 out in front right away. And so what we're integrating is 4 times the integral of u to the negative 3 du. So now I take the antiderivative of that. I go up 1 power and divide by the new power. And we've got this. And so that turns into negative 2 u to the negative 2 plus c, or negative 2 over u to the second plus c. And then we bring u back to get to our final answer. And we've got negative 2 over the quantity x cubed plus 4x to the second plus c. And there's our integral of 12x squared plus 16 over the quantity x cubed plus 4x to the third dx. Alright, example 5. We're going to find the integral of x squared times the quantity 3 minus 10x to the third raised to the fourth dx. Again, our substitution. Notice our substitution choice. After we get through this lesson, we're going to start making the substitution choices on our own. So you want to really pay attention to what the effective substitutions are that we've chosen up to this point. Although we'll definitely get into more complicated ones. Alright, so we're going to end up having a u to the fourth here. Now the only question is what we're going to multiply that u to the fourth by. So we take our substitution, and we take the derivative of that. We get du equals negative 30x squared dx. But what we want to replace in our original integral is just x squared dx. So we'll divide both sides by negative 30, or multiply by negative 1 over 30. And that's what's equal to x squared dx. So I'm going to bring my constant multiple out in front here. And now I'm taking the integral of negative 1 over 30 times the integral of u to the fourth du. I can just go ahead and use the power rule in reverse. That's u to the 5th over 5 plus c. And so this turns into, wow, negative 1 over 150 u to the 5th plus c. Negative 1 over 150, and we bring u back, times the quantity 3 minus 10x to the 3rd, all to the 5th, plus c. And there's our integral. Alright, last one. We're going to find the integral of x over the square root of 1 minus 4x squared dx. Our initial substitution, u equals 1 minus 4x squared. So we're replacing what's inside the square root here with a u. And now we need to figure out what x dx is equal to. So we write down our substitution and take the derivative. Du is equal to negative 8x dx. But I want it to be equal to x dx, so I multiply both sides by a negative 1/8 here. And I'm going to replace the x dx with a negative 1/8 du. Again, I'm going to bring the constant multiple out in front. And that turns it into that for our integral. Now remember, this is negative 1/8 u to the negative 1/2 du. And so I'm going to, again, use the power rule whenever I have a square root like this to take the antiderivative. So this is going to turn into negative 1/8 times the quantity u to the 1/2 divided by 1/2. And so it turns into negative 1/4 u to the, u to the 1/2 plus c, or negative 1/4 square root of u plus c. And then I bring u back, and I've got negative 1/4 square root of the quantity 1 minus 4x squared plus c. And so I hope you're seeing that integration by substitution here is a very effective technique for us to find integrals that are not necessarily obvious to us through antidifferentiation when we look at them. By utilizing the fact that we have a composite function, making a substitution, and we're basically applying the chain rule in reverse here to these integrals in order to find them more easily. And that's what substitution does, is it helps us to apply the chain rule in the opposite direction in order to more effectively find the values of these indefinite integrals. Alright, that's the end of this video and the end of this lesson. See you guys next time. Have a great rest of your day.